This question is on statistics, probability. In statistics and probability, this is a question on normal distribution and to find hypothesis testing, I think. Yeah. So in the first part of the question, we are finding the probability for x value less than 6.5. Now, how to feed this into the calculator? I'm using TI Nspire. So calculator, stats, distribution, normal CDF. You may directly enter normal CDF on the calculator screen. So now here the lower bound, x less than 6.5 means upper bound is 6.5 and the lower bound is 0. And enter mu value and sigma value. And here you get the answer 0.0151 up to 4 decimal places. Next question is to find p-value for more than 7. More than 7 means the lower bound is 7, the upper bound, yeah. Whenever we are calculating values greater than certain value, okay, here greater than 7. Now the upper bound, you can just give some randomly one big number, maybe 100 or like 50, depending on the average. Average here is 6.5. Maybe at least 6.5 plus 4 times standard deviation, that should be enough. That means upper bound could be 6.5. Sorry, how much is mu here? 6.76. 6.76 plus 5 times sigma means 0.12 times 5 means 0.6. Yes, you can just keep it as 7.36. or any value above it, that should be fine. So here I'm just selecting a value of 20. So I'm choosing upper bound value as 20. So when I feed this into the calculator, I'm getting 0.0228. Next is part B. And here we are asked to find expected number of bicycles. Expected value means we need to multiply the probability by the number, okay, number of cycles here. How many numbers of cycle? 1000 here. So we need to multiply by this number n. N is 1000 here. 1000 times. We need to repeat this again in the calculator. Now the upper bound is 6.75 and lower bound is 6.5. When I do this, so here I'm getting 0.451663. So I'm rounding this off to 4 decimal places. 4517, I'm multiplying by 1000 and the answer is 451.7. And the next one, for the second one, 6.75 and 7. So the lower bound is 6.75. 6.75 is the lower bound. What is the upper bound? Upper bound is 7. These two remain the same, 6.76 and 0.12 mu and sigma. The answer here is the probability is 0.510457. I multiply this by n. N is 1000. So I'm getting the expected value to be 510.5. It's done. Let us move to the next part. And here, yes, the measured stopping distance of 10 bicycles are given in the table. So when the actual observation is done, how many observations are done? There are 1000 bicycles, okay, have been observed. In that, they've got this data. Now, we have been asked to find chi-square goodness fit test at 5% significant level. To decide, whether stopping distance of bicycle traveling at this speed can be modeled by normal distribution with mu 6.76 and standard deviation 0.12. What is null hypothesis? Yes, it can be modeled, okay. So can be modeled. That is the null hypothesis. To write it in the keywords, okay, key terms. So H naught, I use the word, H subscript 0. This is how it has to be written. Stopping distance of bicycles traveling at 20 kmph can be modeled by, okay, how to write it now? It is what kind of normal distribution? Normal distribution with, inside the bracket, the first term should be mu. How much is the Mean is 6.76. It's given here. And here we will be writing standard deviation squared, 0.12 squared. Okay, this is how we write it. Alternative hypothesis is opposite of null hypothesis. So it cannot be modeled. It cannot be modeled. Everything else is the same. Next question is to find p-value for the test. How to find p-value? Let us make, to find p-value, we need two lists. One is the observed list, another one is the expected list. What is the observed list? It is already given here, 12, 428, 527, 33. What is expected list? We need to prepare it now. Let us find these two are already given. For the second and the third, okay, 6.5 to 6.7, we already got 451.7. For the values between 6.75 and 7, we have already calculated expected value of 510 here. Okay, where did we find it? It's here. See here, we have already done it. Yeah. In part B, we have already calculated expected value for these two ranges. Okay, that means it is taken care of. Now, what about for x less than 6.5 and x greater than 7? Have we calculated? No, we haven't done it. But here we have calculated only the first part, that is probability part. So how much is the probability? For x less than 6.5, it is 0.0151. I need to multiply this by 1000 to get the expected value. If I multiply this by 1000, it is 15.1. So I enter 15.1 here. This is 15.1. Similarly, for x greater than 7, I go back here. For x greater than 7, here we have got the value of 0.228 as probability. Now I need to multiply this by 1000. If I multiply this by 1000, get 22.8. So now I will prepare these two lists on my calculator spreadsheet. So on the spreadsheet, I am entering these values. Column A is the observed list. Column B is the expected list. Once that is done, next I go to menu, start test, chi-square goodness of it. Now here observed list. Where is my observed list? That is list A, column A. Where is expected list? Column B. Now degree of freedom here. I have got 1, 2, 3, 4 sets of data. So 4 sets of data. So degrees of freedom is 4 minus 1, that is 3. And I want the results to be popped up in column D. So I'm writing D. And here are the answers. It gives all the various answers. So chi-square and then p-value. P-value is 0.072654. So that is my answer, 0.72654. So now to give answers up to 4 significant figures, 4 dp, you can keep it as 7.265. You can add one more 2650, or you can add one more 54. Okay, percentage. Somewhere it is given earlier that we have been told to keep our answers up to 4 decimal places. Now part E. What is part E? State the conclusion of the test and give reasons for your answer. Now I have got a p-value of 7.265. Yeah, this is the p-value, but significance level is 5%. Yeah, 5%. So significance level is less than the p-value. So significance level is less than the p-value means evidence is insufficient to reject null hypothesis. Because it is insufficient to reject H0, that means that accept H0, accept null hypothesis.